Right, hope everyone is doing well. And I guess since we're maybe not Stanford necessarily, but in general, we're a little bit more open today. We're making progress and hopefully getting a little closer to feeling and being a little bit more normal. I guess I wanted to start out today with a paper that we recently published on continuous health monitoring and opportunity for precision health. This is actually a perspective article in Science Translational Medicine. So it's a follow-up one to our original vision paper that was launched right when the center was launched at the same time. And it covers, a lot of the different opportunities and challenges in the continuous health monitoring space. And it's also, it was a special article to myself as well as the co-authors, at least. I'm sure there's been many papers that Sam had a lot of active roles in, so maybe for them, this wasn't the only one. But for me, this was the last one that we're actually able to write together. So you'll see, this one, he is still the senior author, and we're glad to be at least give him this tribute to the center that he was able to build. So feel free to check that out, when you have a chance. It's a great read. We have another exciting, so we have a little bit of a, maybe not a double header in the same day, but we do have a double header in terms of not only Pablo, but in terms of another PHIND seminar that's a joint one with the Center for Digital Health. And it's on the invisible future of health monitoring. So you can see we have some exciting speakers, both from industry and as well as some familiar faces from Stanford. So if you haven't registered already, it's going to be really an exciting panel, and look forward to seeing you there. So hope you'll be able to join us. We also have some upcoming seminars coming up in July and August. So we have our speakers there for that. And so those will be exciting as well. But today we have Pablo Paredes. I'll give a brief on Pablo. He's earned his PhD in computer science from the University of California, Berkeley. He is currently a clinical associate professor in psychiatry and behavioral sciences department and epidemiology and population health department at Stanford University School of Medicine. He leads the Pervasive Wellbeing Technology Lab, which houses a diverse group of students from multiple departments such as computer science, electrical engineering, mechanical engineering, anthropology, neuroscience, and linguistics. Before joining the School of Medicine, Dr. Paredes was a postdoctoral researcher in the computer science department of Stanford University with Professor James Landay. And during his PhD career, he held internships on behavior change and effective computing at Microsoft Research and Google. He is an active associate editor for the Interactive Mobile, Wireless, and Ubiquitous Technology Journal, and a review and editor for multiple top CS and medical journals. So he has a number of really interesting activities, very, very unique background, and we're really excited to hear from you today, Pablo. So I'll turn it over to you.
Wonderful. Thank you so much for having me over. Very excited to be here. All right, I'm going to share my screen. All right. Can you see it well?
Yes, looks good, Pablo.
Okay, great. Okay, welcome everybody. Thanks for having me over again. Indeed, I am at Stanford, currently actually on leave, working on a startup that's a spin-off of one of the projects that actually started in CS, but also evolved at the PHIND Center called Pop-Up Health. So I'm there for the remainder of the year. And I'm here to present the topic of pervasive computing for lifelong resilience and well-being. So when I was in Ecuador, I had the opportunity to enjoy playing music. I'm a musician as well, playing with my brother who's on the drums, and I'm on the keyboard, as you can see. It was a pleasure, enjoying very many good moments with him, but also there were some sadness. He sadly suffers from an anxiety disorder, very debilitating. And because of that, I had to, look for opportunities. In Ecuador, there's very little that can be done, and very proactive type of work. So at some point I was able to be his supporter, caregiver here in the US while he was going treatment, and he improved quite a bit with cognitive behavioral therapy. But also during his time here in the US, he used to, you know, comply with his demands using the alarms from this old phone. But he played quite a bit of this game also, this soccer game, which I was actually pretty, you know, interested of why he, you know, I asked him, why do you like this game? And he said, well, it really actually helps me reduce stress. Like, you know, when I'm anxious, playing this game actually helps. So that was actually a very interesting moment to me. I said like, well, maybe there's a more that we can do with technology. And that was the inspiration for me to actually start thinking more and more about this topic. So I basically quit a business career in strategy and product development for, you know, many years, and they became a scientist on this study of stress resilience and well-being. As you can see, I have a background in engineering, but I'm currently in the med school. So this is actually a pretty exciting transition and something that's happening more often, you know, we're having this multidisciplinary approach. Ultimately, what I'm interested is in this concept of health. Basically the definition that has been given like many years ago by the World Health Organization. You know, it's a state of complete physical and mental and social well-being. Because it's not so much about curing disease, but it's more like how do we keep people strong. I've been most interested in this topic of stress because of the pervasiveness of the topic, and also because of the lack of like support. I mean, despite all the impacts on productivity and also in health, there's just no infrastructure out there to manage stress. And people from, you know, all around the world, they don't just suffer from stress, but they also don't know what to do with that. And they get very little support. So that's something that I'm actually quite interested. Ultimately, what I'm interested is also looking at, you know, finding these people wherever they are. You know, we spend a lot of time indoors, and now the modern stressors are actually not so much about survival mechanisms, more about perceived demands and threats. So I'm very interested in how to do this stress management in the modern world, you know, which is, you know, chairs and desks and cars and the different places where people are, and, you know, how to do technology that helps us do more sensing and also interventions that are embedded in these new environments. So I would like you to imagine, for example, can we actually repurpose the internet as a source of like real interventions, like things that we're really doing on the internet? Or what if we can actually repurpose messaging apps as potential interventions, like simple interventions that we can have constantly? What if we can have your car guiding you to breathe when you're commuting to manage stress? Or perhaps even your furniture, you know, help you regulate your breathing when you're like working at the office or home office. Or maybe even like desks that make you move more and help you like be more active and, you know, reduce also the effects of stress with activity. Or even tiny robots that basically work with you and they try to provide you some like comforting signals when you're working, especially for like teenagers and younger people. What if you could potentially sense the stress using a mouse? Just the movement of the mouse, a regular $5 mouse from Walmart. Or perhaps even the steering wheel of a car, a commercial car that's already, you know, being deployed in the wild. So these are all some of the ideas of the work that we've been thinking and making some progress. And we basically work a lot on these multi-domain and multimodal sensors and interventions for stress across multiple domains such as work, the commute, and in general life, and all the different interactions between these different groups. Here's a list of some of the publications that we've done, both on sensing and interventions. Of course, I won't go through all of them. I will just highlight a few during this presentation. I'm going to go through essentially two parts in this presentation. First, some ongoing research and then future research agenda. So let's start with the beginning. On the ongoing research, basically focused on stress and sensors and interventions. I'm going to talk about three topics. The first one, sensorless sensing or passive sensing, just-in-time interventions, and peripheral cyber-physical interventions. So let's start with the first topic. Okay, so, from the first paper actually that Sam and Ryan wrote, one of the important visions is like, how do we have this notion of precision health? And the need is to find sensors that actually allow us to continue to monitor the human body, go from this like very undersampled situation of one doctor's visit per year to more of a jet engine, try to like have the human actually to be monitored also a very high, sampling rate such that we can do early failure detection and prevention. To do that, we have to develop sensors that are importantly, adaptable to the different situations. And of course, wearables are really valuable, but one of the issues with wearables is that, there are higher levels of dropout. Like I used to wear, for example, a Ring wearable, and now I'm not doing it anymore because the battery died and I didn't charge it for a couple of weeks and now it's dead, or things like that. So I'm not compliant anymore for the past 2 months. And I quite honestly needed that because I have a sleep disorder, but still I'm not compliant. It's just, that's the problem with wearability in some senses. So that's part of the inspiration to think about devices that you already have on your office, like the mouse. And we basically propose that we can actually look at the way you move the mouse, do a biomechanical model using this model called mass spring damper, observe some variables such as the damping frequency. And I'm happy to explain these, mathematical models to you more in detail if you need it at the end. And essentially, we show that it is possible to use a regular mouse and just the way you move your hand as a valid, sensor. So we basically run an experiment where we have these different tasks where people have to click on one side of like this block, the blue block, and then to the yellow, or traverse some kind of like passage, or like drag and drop things. These are canonical movements of the mouse, and we vary the width and the distance. And then we modify, we have like a stressor, condition and a baseline condition, of course, counterbalance. And then we show that it was possible to actually prove that. Of course, it's not easy to see, in the naked eye, the differences. Here are some plots of like the movements of the mouse on the x-axis for stress and non-stress. You will say, well, pretty hard to like detect a difference. But when we applied our models based on like some kind of what's called adaptive filtering, we were able to discover that the damping frequency indeed was, as you can see here in the upper part, indeed was like different for the calm versus the stress. And not only that, but for all the different conditions that I show you for one of the interactions, the mean was actually different across this feature called the damping frequency, which is actually, for those who know biomechanics, this damping frequency is associated with what's called the K coefficient of a mass spring damper, which implies that it's actually the tension, which we basically draw a parallel with muscle tension or muscle stiffness. So, and those who know a little bit of biology know that, when you get stressed, your muscles actually get tense. Your limbs especially get tense. So we're very happy that there is like this clear, clean observation of like, the correlation between stress and muscle tension observed through the mouse. And we even applied some simple classifiers where we were able to get up to 70% accuracy, over this model, this sawtooth model that we created. Again, happy to explain more the details if needed later. More recently, we also wrote a paper. This was an experiment actually that we ran at the PHIND Center, in my lab, where we actually showed that also the trackpad can be used as a sensor. In this case, what we found is that the area under the finger, so basically the amount of occlusion that happens with the finger changes when you're stressed. If you do the exact same tasks, which we actually replicated the same tasks that I showed you earlier, the point and click and the drag and drop, etc. We also observed this, and we recently published this paper in JMIR. more recently and more exciting actually is that we've been working to take this technology out of the lab, and we have been working in two populations. The health practitioner burnout in collaboration with the family medicine people. We actually already ran a pilot there, and we collected several labels of stress across 4 practitioners for over a month. And we actually detected, we're getting very excited because we're finding that, you know, we can get up to 85% detection between like high stress and low stress. And this is in a fully, you know, no abstractions anymore. This is the real work of practitioners using the mouse in the Hoover Pavilion family medicine, actually. So our hope is that we can collect more data and eventually, you know, show that it's really, this technology is translatable to the wild. We're also working with CPHS to try to reach out the rural health workers, you know, through, in this case, more the smartphone and use our technology. Sadly, the pandemic has really affected this project. You know, because of the pandemic, we kind of had to stop the work, but hopefully we will re-engage whenever it's appropriate. Our hope is that, you know, we can actually embed our technology in smartphones in that case. Another spin of this technology of like biomechanical modeling is also in the car. We actually ran a study in the simulator when I was actually I ran this study when I was a postdoc in CS, where I basically wanted to see the displacement of the steering wheel. You know, as you can see here, plus minus, you know, the displacement of the steering wheel to the right is positive numbers, to the left is negative numbers, and basically create also biomechanical models on this angular displacement. And we were able also to show that this can actually be modeled again with the same mass spring damper model and the damping frequency. But more exciting even is that we actually ran an in the wild study. This is actually footage of the garage of the 1701 building, the former Theranos building, where my lab used to be when I was in PHIND, in radiology, sorry, in PHIND. And we ran this study, and we already have this submission ongoing, where we also show that with a real car, real humans driving in a real scenario, real world scenario, we can also get this data out of this system out of the lab and actually work. So in summary, sensorless sensing is an idea that where we want to increase compliance by using technology that you already have, like the car or the mouse or trackpad. It's affordable. You don't have to pay any hardware for it. You just need to do software. And we're talking about millions of devices that can be actually used to be sensors for stress, or maybe billions with a B. So really going over the vision of Sam and Brian on, like, you know, this like sensing constantly, you know, in your own environment. The second part of the ongoing research is this just-in-time intervention. So it's like, well, you're sensing, but then so what, right? So one of the notions is, how do we manage this by having multiple interventions and then use algorithms to discover how to apply that? So this is the inspiration for this work comes from the notion that, you know, people who are healthy are not so interested in health. You know, the definition of health of like just being strong. It's when they lose health that they become interested. So if we were to do proactive medicine and keep them engaged, how do we bring them back? Is by doing engaging design. And one of the options of doing engaging design is to maybe repurpose things that you already do that are pretty sticky and engaging. So this work actually started a few years back when I was in Microsoft, where we were trying to basically get, you know, an app that adapts to your needs. And when you're stressed, you can basically use your phone and basically request an intervention, and the algorithm will know what's your context, taking information from the phone, from multiple sensors, and eventually it will provide some kind of interventions. It will assess your level of stress, and based on that level of stress and the reduction that happens after that, it will adapt the algorithm to give you the best type of intervention that you can choose. The notion is actually based on the observation that in reality, stress is not a problem. It's how you cope with the stress that's the problem. And there's a lot of different types of modalities of coping with stress. Not all of them are good. So the idea is to try to find those what's called constructive coping mechanisms, which provide long-term change and improve functioning, versus those destructive mechanisms that actually don't do good and actually generate more stress in the longer term. So how do we help people learn to cope more constructively was the objective. And to do that, we wanted to, again, be as engaging as possible by repurposing apps that they already use into applications that may be useful as stress interventions, and use machine learning to find the right policies to recommend these interventions, and then measure the long-term change in the change of, the coping change. So we basically combine HCI and AI all together from the design, of these microinterventions. We use information from the phone, as I said earlier, and we repurpose these interventions. So essentially how it works is you have this app, and we created these interventions that are an intersection between pop culture, like popular apps and games and media, versus top therapeutical approaches for stress. And we create interventions like, for example, this one. It's very simple, a prompt and then a link to your Facebook timeline where you basically go and look at something interesting. And this is a positive psychology-based intervention. It's called the 3 Good Things. Or this other one where we try to get you laughing more, just to have some like insertion through laughter. At the end of the day, we created 16 interventions in 4 categories: positive psychology, cognitive behavioral, metacognitive, somatic, and 2 types of interventions, individual and social. Individual meaning you can do it by yourself. Social means you have to interface or interact with some other human. So we tested all these interventions using the machine learning algorithm called the contextual multivariate bandits that basically go through these phases of exploration and exploitation. Exploration meaning you go and traverse and test all these different interventions at the beginning to see which ones work for different people. And then when you find those who seem to be more valuable, you exploit them and use them more often. So that's called the decision space. Then you use contextual information to basically, as one of the inputs, to try to know where you are, what you're doing, et cetera, in order to train the algorithm. And then the very important outcome, which is the reward, which is the amount of stress or the change of stress in this case, that will be basically the factor that we're trying to optimize for. We ran an experiment over 4 weeks where we ran more than 5,000 interventions with 95 users in 4 different conditions. Those who received random and those who received machine learning guided interventions, and also we gave some people the chance to override the decision of the system and others don't. And we collected a lot of information, on a daily and weekly and pre-post basis. At the end of the day, what we observe is that the machine learning no override, the one that you basically do what the machine learning tell you, had a much higher reduction of stress. It's still a very minor effect, but was the biggest reduction, on pretty much every day of the whole month. And the cumulative effect actually was great. We also saw like almost like 100% more deviation towards like constructive coping abilities during the whole month as well. So this is pretty exciting. If you look at, how did the interventions converge in the machine learning conditions, you will see that, even though each of these columns represent one of the different users and they have different combinations of interventions, because that's the purpose of the personalization of the algorithm, the most preferred ones were not the usual suspects like cognitive behavioral therapy. As a matter of fact, people actually found that to be the least interesting. And one of the reasons they told us that is because CBT is just more like homework. And in this tiny micro intervention format, they actually didn't like. They prefer something like just some simple movement, like the somatic interventions, or some kind of easy reframing like positive psychology. A couple of other side lessons that we got were that people got bored over time. In that case, this graph, pay attention to the scale on the y-axis, shows the 2 machine learning versus random conditions. And in the machine learning condition at the beginning, people were not so compliant to the recommendations. So this is actually the override group. And over time, they started complying a bit more with recommendations for machine learning. But about after 2 weeks, they started again exploring other options, overriding the machine learning algorithm. And one of the reasons they told us is like, okay, I get it. Like, breathing is really good for me. It's just boring. Like, can you give me something else? Or among the people who dropped out, we got like, some people actually dropped out, not because they couldn't or didn't like the intervention, but mostly because they say, okay, I get it. These are simple things that we can do. I don't need an app to tell me this constantly. So that's actually a positive effect from a, health perspective. However, one very important side effect that we also learned from that study was that, a big chunk of the users, actually the ones who dropped very early, basically found that the stress management app actually was stressful to them. And that's kind of like interesting and paradoxical, because they basically said the fact that I have this app in my phone just keeps, makes my stress more aware. And some people would say, well, awareness is fundamental for behavior change and improvement, but sometimes it can be also an exacerbating factor, especially if people are not able to like comply with the proposed interventions, mostly because of lack of time. So that's why they prefer to basically drop out of the study and uninstall the app. Another continuation of this work that we did with micro-interventions online, it's actually what we can do micro conversations, right? Because messaging apps are the #1 type of app being used nowadays. So we basically changed the micro-interventions with micro PopBots. This is work that got some funding from HAI, from the Human Center AI Center at Stanford. And it's actually what has been spin off as a startup, and where I'm working for the next few months raising funding for the startup. And this, of course, the evolving within the PHIND Center, and run several experiments. During those experiments, we basically created these little chatbots here where you have these conversations, and you have essentially the, people talking to the chatbots and having like first, assessment of what's going on, and you can actually get more information about what's stressing you out. Is not just the level of stress, and we use that information in order to process, what the selection of the best PopBots. And there are several PopBots, and some of them represent different techniques. Like this one, for example, is the Sherlock bot, the one that's problem-solving therapy, versus the Glasgow full bot, which does positive thinking. So we use different techniques that have been already proven in the wild, and we basically transform them into conversations. Ultimately, we found like, some quantitative early results is where those were like short studies. Actually, the paper is coming very soon in JMIR 21. It's actually in press right now, has been gone through the whole review cycle. And as I said, we found some quantitative findings that depression actually went down from a for those who were heavy users, the ones who used twice as many chats than those who actually use less. We had a significant reduction in this PHQ-4 questionnaire, which is a typical tool used to assess depression and symptoms. But another very exciting finding also was a qualitative finding where we actually compared, we asked people to tell us, which kind of chatbots will you prefer for different stressors during the day. And then we actually told them, what if you can have also humans involved? If there were humans who are always available, we made that abstraction. Would you prefer humans or chatbots? And much to our surprise, or to my surprise, people actually wanted to have chatbots. And in some cases, they would prefer chatbots over humans quite heavily. So what one of the participants told us is that she would prefer an ecosystem of chatbots and humans, where chatbots are these new species of treatment that are not necessarily a replica of humans or an abstraction of humans, but more like a simple, these quick conversations where with a chatbot they actually appreciate it. So we hope that this is the future where there's an ecosystem of chatbots and humans. So in summary, this just-in-time intervention suites is a combination of a lot of like micro interventions to reduce the barriers, repurpose things that you already do, like messaging apps or the web, We can personalize and contextualize with advanced AI algorithms. And again, these are just in time because of the nature of like being things that you already used, and you can actually show that these micro changes actually accumulate over time. Finally, on the ongoing research, I want to talk briefly about these like peripheral cyber physical interventions, which is another way of thinking about interventions. These are more like what we call online interventions, things that you can do while you're actually doing something else. One of the things that I'm very excited is about breathing and how to bring normal breathing down to like lower levels of breathing. In the case of like, you know, experts, they can go down to like almost 6 breaths per minute as compared to like 12 to 18. And I actually tested these in the beginning, doing a very early study that I did when I just became a student. And I realized that, you know, this deep breathing is actually complicated. Some people can do it really well if you're a practitioner, but some people actually hyperventilate if they don't know how to do it well. So we actually are more interested in what will novices need to do to start breathing slower or better, which is just reduce your breathing rates by 30% and see if we can actually do it in a peripheral guided way. So for me, one of the things that I was interested is to how do I repurpose the commute as an opportunity where you can be driving and breathing? Can we actually do it? So we started doing some early explorations of like, will people actually do things in the car, like breathing or moving? And we had some paper in JMIR on this notion, and people actually showed some interest in doing these things. And mostly the commute is interesting because of the amount of people that actually commute every day in the US and the time they spend. So it's a really interesting opportunity to do some kind of like stress management. And it's one of those times where you actually don't feel you're wasting your time. You know, you're actually don't have a good definition for the commute. Most people, when you ask them like, would you do something else during the commute? People will just say, sure, yeah, I have nothing better to do, right? It's not like, no, my commute is sacred or something. So we basically wanted to see first in the simulator, we can guide people to breathe. And we showed that, you know, as you can see from 19 breaths per minute, go down to 11 in about 40 seconds in both like driving conditions and also in the autonomous driving conditions. And the only side effect was this guy falling asleep, you know, in the autonomous driving condition, because basically you're doing nothing, you're just breathing slow. And so you have to be careful if you're doing autonomous driving, if you think that deep breathing is good, for your health, it will be good, but it may kill you if you're not paying attention to the car. But the really exciting work actually happened, and this is actually already published in the journal of Input Journal, where we again ran another experiment. This is a different experiment, also in the garage of the PHIND Center, down below the 1701. And that's why we claim we have the first lab actually in that building. We were the first active lab, which was the garage. And we actually show that this can be done in a real car with real people. We actually created this mat that basically guides people with haptic signals, which is actually a new contraption based on what we did in the simulator, which actually was attached to the seat. And we ran an experiment where we had this, we contrasted, you know, the intervention versus a control, of course, but also we wanted to see what happens if we add a stressor also. Will actually the intervention work? And it was actually really nice to show first that, you know, we can actually get breathing rate down, you know, with a guided haptic mat. When you have like, you know, a baseline, a normal conduction, you know, you don't have a stressor involved here. You're just having your normal breathing rate going down by 30%, about 30%. But more excitingly, when we actually added the stressor, people were able to reduce the breathing rate, and actually the breathing rate reduction actually went down, stayed down even after we removed the intervention, which is was applied during the phase. And the heart rate variability, which is a measurement of actually how arousal is expressed through like stress, went up, that means that people got calmer. Heart rate variability went up and stayed up too. So this is pretty exciting. And this is what we published again in this paper with my former postdoc, Stephanie. Furthermore, we also added these cameras on the side of the car that we actually used to measure the distance with like these white lines that we also tended, we put it lined up on the whole garage, and we measured the deviation of the car and also the heart brakes as measurements of performance and safety. And it was really nice to show that also there were no substantial safety degradations, just a minor performance degradation, which is not really threatening. That means that this technology could potentially start going out in the wild. As you notice, this kind of car technology, we always start in the simulator, then we go into closed circuit, and hopefully, with funding, possibly like replicated also in the wild. So safe to move on traffic testing. So the conclusion on these peripheral cyber physical interventions, we can repurpose space and time. You just use a chair, like you're sitting in the car or maybe even in the office during the commute. They are efficacious and engaging because you're basically like just doing the same things that you're doing, but also helps reduce stress. And so far they are safe, at least the ones that are in the car. So I've shown you this ongoing research and sensing and interventions and two kinds of interventions. And now I'm going to go kind of quickly on the second part, which is the future. But I wanted to bring a couple of questions before that. I want to make sure that we also think about the ethical considerations of the work that we're doing. Like, we're ultimately doing surveillance, so we have to think about like how can we like manage these surveillance problems, right? We have to think about federated learning or local computing and privacy preserving algorithms, maybe like having chips that manage these kind of things on different devices to actually avoid privacy issues. How do we actually get, consent and autonomy managed? I don't think a single consent should be enough for this kind of work. We should have to have ongoing concern or shared permissions for different type of data aggregation, depending it's a doctor or public health. And also, how do we prevent malicious use, right? How do we prevent people using this type of technology incorrectly, right? Maybe if we democratize data and code, it will be at least, useful for a community to detect these malicious activities, even if it's harder to regulate or prevent. So some ethical considerations that I think we should think. All right, so now I'm going to glimpse very quickly on some of the ideas that we could do in the future, mostly for your inspiration. Some of them have preliminary results, but mostly are like, very early, ideas. And my hope is that we can think about sensing ecosystems, multiple ecosystems, and stress management and its implications, also not just the stress management itself, but also what's the implication on different aspects of life. How to use different types of levels of autonomy for well-being, like now that there's so many robots and AI being deployed. And finally, what kind of interventions we can do that may be beyond the persuasive types that we're used to. So let's start with sensing ecosystems. We actually got a grant last year through NSF with Jenan Bao and Mert Pilanchi, chemical, and we're combining biochemical sensors from Jenan Bao's lab, where our biomechanical sensors and Mert Pilanchi's AI multimodal sensing algorithms to do a lot of interesting combinations between like cortisol, HRV, and EDA sensors, traditional psychophysiology sensors, with our novel passive sensors to improve different type of issues around power or reduction of motion artifact issues, or also just learn how to collect data in order to train these AI contexts. We were given this award last year, and we're working actively on this project. So creating this ecosystem of multimodal sensors, which I think is the future of precision health. One of the early works that we're doing is actually how will people adopt these new kind of wearables that are complementary to the passive ones that I showed you earlier, the passive non-wearables one, based on Jenan Bao's work. We actually have this under submission, this paper where we use a new cortisol sensor that she's been developing. We actually got some funding a few years back to work that, and I was part of that project. One of the interesting projects that we came about is combining the biosignals design with the human factors elements, which we're experts on that area, the human factors. And we devised this kind of formula where we can combine human preferences for where to put these sensors for stress, which are can be adhesives that go on your skin, versus like where will engineers prefer to get the best signals. And we found that, we can combine those two preferences or those two body maps, and find the ideal places to locate these sensors. Like in this case, people prefer the sensors to be concealed versus like the places where engineers would prefer to measure the signals. And we found that the best average between the two might be something that you can wear on your shoulders, under your sleeves. The next topic is stress management implications. Like, I would like you to think about stress, not only as, the objective of like research, but also the combination with important issues like performance. Can we actually measure both arousal and performance? There's prior work by, Yertz and Dodson that shows that stress and performance are linked via this inverse U curve. And, we hope to optimize for the place where you have enough stress to perform and not so much that actually reduces your performance, but not so little either. And there's other research done by other researchers that show that for different tasks, this curve actually is quite different. But the reality is that in the wild, there has been almost like no real assessment. So we're building actually a system where we're deploying, this is a Chrome plugin where we're actually providing, we're sensing and providing interventions for stress and productivity jointly. We call this the Home Suite Office plugin, and it's one of we got some funding to work on this because of the pandemic. And we're hoping to basically understand your productivity by understanding when you spend not useful time in social media or other apps that self-defined by the user, but we also keep basically monitoring all your activity by your mouse and the movement through the Chrome plugin. So we hope to create curves, maybe not of stress versus productivity, but maybe procrastination versus stress, and start trying to understand how to optimize, not just for stress, but also for the purpose of one of the effects of stress has in productivity in this case, for example. The other idea that I wanted you to think about is now that there's a lot of AI and robotics out there, how do we use that for well-being? So one of the concepts that we've been exploring, and this actually happened, the pandemic did have an effect in this research, is humans are increasingly, exposed to autonomous devices, but humans actually prefer to keep control as opposed to relinquishing control to the autonomous device. The thing is that with a simple behavioral economics analysis, the preference of using autonomous system goes down as more autonomy is provided. If we make that bold assumption, and if we assume that an autonomous system is actually providing a better outcome, a simple combination of these two things will show that there's a surplus where we're actually not getting the benefits of fully autonomous system just because humans don't want to do them, right? They want to use them. So how do we help them adopt these kind of systems? This is something that we're interested. Of course, there is a risk of de-skilling. We don't want people to also forget how to manage their own life and just relinquish it to an AI system or outsource it to an AI system. So should we design wheelchairs for health, or should we design chest crutches to help them get back on their feet? And one of the projects that we're working on this topic is this low intensity physical activity in conjunction with Abby King and other researchers, where we're basically from prior research that shows that bouts of low intensity activity are better to reduce mortality over time. We have been investigating sit-stand desks as a form of automation, where we basically noticed that people get very excited at the beginning using sit-stand desks, but over time they lose interest due to apathy. They just don't want to use them anymore. So we build this automatic desk that goes up and down, and we call it this non-volitional behavior change. We actually not just nudging you, but the desk actually forces you in a way, right? Or let's say trains you, that's a better word, to actually move more during the day. So we were working, actually, we had this system working and it was ready actually to be deployed, in the PHIND building, but sadly because of the pandemic, we had to stop. So the next best thing we could do is we actually did cultural study with like, vignettes, video vignettes, where we show different levels of automation for this desk, from manual to autonomous. And, and a couple of intermediate steps, one called notification, which is like it asks you for permission every time it needs to go up. And the other one, set and forget, which is you choose the level of like, oh, there's the frequency of movement once a day, every day, every morning. And what we found, which is actually pretty interesting, is that, there's pretty different cultural preferences for these kind of levels of automation. As you can see here in India, all the different desks, all the different levels of automation were actually pretty stable. Maybe a little bit more preference for like manual, but in the US, people would prefer either the manual or some level of control, but definitely not full automation. People don't like full automation. And some of the interesting reasons they give us is like, this is just not okay, like that you just tell me when to move and that infrastructure has the power to like control my life. So it's all about control, which is quite interesting, right? Maybe it has a correlation with like mask usage too, right? Who knows? We didn't do that kind of assessment because we did it during the beginning of the pandemic. But anyways, this vision of like, shared autonomy is something that we need to work, and culture plays a role, and also gender plays a role. And we hope that we keep exploring these kind of like ideas with sit, stand, desk, or other kind of automated health devices. Finally, the last thing that I wanted to bring to your inspiration is like, can we do something beyond persuasive devices? So one of the things that we're interested in is like, what if we can use subconscious reality to the mix of like different interactions that you can have? There's real interactions, and then virtual reality that some people are doing, or augmented reality, and even augmented virtuality, where you combine reality, some elements of reality into a highly virtual world. But what about the subconscious reality? Like, at the end of the day, humans use a lot of interoception to make decisions, this inner ability to understand what's happening inside your body. And we can also know that we can influence some of these interoception, some of your body rhythms with these notions of entrainment. So based on these couple of ideas of, the notion of like interoception and entrainment, we actually went on and say, what if we can go from that guided breathing chair that we did earlier into like an entraining, like with an E, right? Breathing chair that actually can like modify your breathing rate in a passive way while you're sitting on it. So we created a biomimetic, signal that replicates a breathing rate. So basically the chair breathes, and it breathes with this low frequency transducer that helps generate feelings within your body, feelings of low frequency, but actually those feelings of low frequency don't necessarily can be heard outside. So imagine this low frequency transducer more like a subwoofer without the membrane. So you don't hear the beats, you only hear them across your bones, right? Through your bones. So only the person who's sitting on the chair will feel this breathing chair. And you can like basically modify the different carrier frequencies to adapt to different preferences, and even manage the amplitude of this signal to a level that might be considered by psychoacoustics, that's called like below your liminal level, your perception, below perception, right? And you use some techniques like two alternative force choice to find this liminal level. And we did already some preliminary assessment of this, and we ran actually a pilot with 4 people where we found that the subliminal version actually was able to reduce breathing rates compared to a baseline, and a bit better compared to a control. And we contrasted also with a supraliminal, where people can feel the vibrations, where there were some reductions, but the subliminal had an edge. Of course, this is super early, and sadly, because of the pandemic, also we had to stop bringing people to the lab, and this is inherently a cyber physical project, so it's really difficult to like do anything without human subjects. So we hope to re-engage once we're able to move forward. But again, this is bringing the subliminal aspect. So these are the different inspirational ideas that I brought for what can be done in the future. But we should keep asking ourselves also the ethical questions, like, should we really do automation? Like, what happens if we automate desks and chairs and things, like will be de-skilling people, right? And how to manage their emotions and their life in general, their health life. Is there like, a societal cost benefit of pushing more automation? Another interesting question is, wait a minute, here, should we operate at a subconscious level? Is this even ethical to operate? Like, of course, there has to be an opt-in, but even then, like, what if there's malicious, actors who might have these kind of subconscious like interactions? And should we see these more as an assistive technology to help people like, manage stress, especially if you have some kind of disorder? Should we have scanners for like the subconscious actuation, like, that we should manage? I know there's other researchers working not just with haptics, but also with like volumes in music that can actually be much more pervasive. So at the end of the day, after all this conversation of the past and the present and the past, is we need to, I keep asking myself, like, how much sensing do we really need? Are we we're going through a medicalization of normalcy? Should we be more careful about how we think about these things? Or should we also think about stress hygiene, for example? Why do we need sensors of stress? Why don't we just develop the hygiene? Like, we don't wash our hands because there are sensors on the hands that tells that they are dirty. We have more this notion of hygiene, right? Can we actually push towards that? Another reflection is like, interventions are not an evolution of sensing. Even if you know how to sense stress, that doesn't mean that you know how to remove people's stress from existence. So I want to like make a call that, research or interventions, even if it's qualitative or early, is also very informative to help us understand not just efficacy, but also engagement, right? And we should think about like, interventions that are not necessarily replicas of existing therapeutics, like the micro chatbots that we did. They are not replicas of humans. These are new species on the ecosystem of interventions that we can create. Who are we benefiting, right? Are we really like creating, a better world for everybody, or are we creating more health disparities with all this technology that's coming? We actually create true public and population health technology. That's why in my lab, we want to use like $5 mouse or like sensors that already are existing in cars or messaging apps, things that people around the world can adopt, versus like complex contraptions that require like advanced wearables or like complex things that you should wear in your home. So in summary, I've told you about like, these multi-domain sensors and interventions across multiple devices, and, work that we've done, some of the work. All this work also combines the scientific method with human-centered design. And, this is just like a map of all the things we're doing, and some machine learning and a lot of implementation thinking, how to get this in the wild. Basically to not just work on efficacy, but also engagement, and find the sweet spot, as we move towards like this proactive world of like prevention and also precision health. And this is basically the nature of my lab, the Pervasive Wellbeing Technology Lab, where we do this work for a living. So thank you so much for your time, and this concludes my presentation.
Excellent. Well, thanks so much, Pablo. That's a large number of different interventions you have undergoing, and it's ongoing, and it's it's really a pleasure to see kind of the evolution of what you've been thinking and working on over the years. So I think, if anyone has any questions for Pablo, either raise your hand, we can call on you, or you can also type your question in the Q&A. And while everybody's thinking, maybe I'll kick it off. Yeah, I mean, we spent a lot of hours, talking about all these different things. So, super cool. I wonder, you showed that, some of the effects of the interventions can be like lasting longer. Like if you stopped, the intervention, you still saw the beneficial effect. I think about it, and you have so many different interventions. Are these additive? Like if I did one and I waited an hour and did the other, would I see a benefit? I mean, I'm sure just like the other things, there's like some threshold of balancing of the different elements. But kind of, what are your thoughts on that?
Well, the additive, if you think about one of the projects, the one that we did, that suite of interventions where we combined different types of therapeutic techniques, the format was the same. It was just an app I think you can combine those with other types of formats like the cyber physical interventions, or like different levels of intervention, from like very swift and quick, like the ones that we did, versus like something that requires maybe taking a break for a longer time, or maybe doing meditation or whatever. I think, quite honestly, and that's actually where I want to go at some point, is that we don't just need ecosystems of sensors, as I said, but we also need ecosystems of interventions. Like, and these interventions should be basically always there, and hopefully, you know, we can learn through algorithms like, you know, reinforcement learning, which I showed that example with multidomain bandits, other types of algorithms, or even with heuristics. We can learn which interventions work for whom, when, and what are the best ones. I think the cumulative effects will be shown mostly on like the reduction of certain larger amounts of signals, like for example, the coping mechanisms or depression symptoms. I don't think the stress reduction is gonna be necessarily going increasingly down. Sorry, the stress impact. I think the maybe over time people will learn to prevent a little bit also, you know, getting too stressed, and maybe that's a side effect of the interventions themselves, like some kind of like, oh, now I notice that, you know, I'm noticed that I'm going to get stressed because of something, and that will help reduce maybe the impacts of stress itself. But I think it's more the cumulative effect will happen more on the prevention of like depression symptoms, anxiety symptoms, even mobility and these kind of things. That's my expectation, and hopefully the work that can be explored in the next few years.
Excellent. Yeah, thanks, Pablo. Looks like we have a question now. After all this research, can you share your latest thoughts on measuring stress? It's been notoriously tricky phenomenon.
It's very tricky.
Are you still a believer of the HRV, RM, SSD, for example?
I mean, HRV and RMSSD, it's something that works as long as you have a very controlled study, right? I mean, if you have a very controlled study and you know how you're getting the data, and you do it in a very clean way, and you know how to analyze it, then of course there's like a strong correlation between those signals and some level of arousal. In the wild, it gets really tricky, right? In the wild, and I mean, I've spoken this with Nima. I know Nima is asking the question, right? I mean, it's like, how do we really keep track of these things in the wild? It's not simple at all. Like, they are really affected by motion artifacts and by context and by a bunch of other things. So I personally don't use these kind of wearables, again, as you know, are my guiding force outside. Like, sadly, you know, right now, for example, the mouse thing, the way that I'm collecting data is still some kind of subjective assessment combined with the movement of the mouse, which is easier to get because it's on a table and it just doesn't move, right? It just moves based on what you want to do. So it's a cleaner signal. I would say, again, it depends on the application. You know, if the application is to understand, like, you know, acute stress constantly all the time and use these sensors as your ground truth, I will argue that's very, very, very hard, very tricky, and very like dangerous even to like assume that they are true, right? You should be aiming towards something else. That's why we're actually pushing this ecosystem of sensors, right? That's what we actually wrote on the NSF proposal that we got with Jean Bao and Pervasive. We actually say, we know all these sensors are imperfect, so we need to combine them and then see what happens if you combine them all, and you use advanced algorithms to actually extract the moments when you can have a higher level of like certainty on the measurements from different type of interventions. And on the combined force of these sensors, hopefully we will get higher levels of precision over time. So I definitely think that we need to work towards ecosystems of sensors. I don't know if that means like a single device or multiple devices. I think it most likely will be multiple devices, but that's my perspective. Yeah.
Excellent. You have another question. Could you talk about how you induce stress for some of the studies that evaluate stress, no stress conditions, right, such as the mouse experiment? Or do you survey participants during the study about whether they were stressed or not to compare the measurements from various experiments?
On the control experiment, the first experiment, we did induce stress, yeah. And we used one aspect of the Trier stress test, which is a famous test that has been used over and over again in psychophysiology, which is the math part of that, where you get people to do subtraction of a number from a prime number, and you start subtracting prime small numbers. And at the beginning, it looks not so complicated for some people, especially those who are in engineering. But over time, they make a mistake. And every time they make a mistake, that induces like the amount of arousal. And it's pretty much a guaranteed stressor. Like I've run that stressor several times, and it works really, really nicely. Like it rises your arousal level or perceived arousal level at least twofold, you know, most of the time. So that works in the control environment. In the wild with the doctors, that's definitely serving. That's called the experience sampling method. It's a method to basically at random times during the day, you collect the level of stress and you use that random measurements as, you know, your basically labels for training the algorithms. In that case, we're not inducing stress. We thought about inducing stress. Like, for example, we were taught, like, what if we fake that the internet goes down? We can manipulate your Wi-Fi signal for like 2 minutes and make it like bad for a little bit. But it's a really tricky ethical problem, right? I mean, if we can manipulate stressors in the wild, but we could potentially in the future. It's an interesting idea that I would like to test at some point. Yeah.
Yeah, looks like another question from Nima on what are your thoughts on interventions that aim to reduce stress versus enhance the opposite?
Of course, we definitely have to enhance the stress. Like I think that's a very important one. And actually the breathing one, I have a exploratory paper where we actually increase the level of breathing rate in the car drivers. And we actually were thinking of, like, you know, when you start feeling drowsy, for example, for truck drivers who have long haul, you know, cycles where they may actually need to increase. This is not necessarily like increasing stress. Maybe you can argue that that's increasing like attention or something, but definitely the mechanism is the same. It's the breathing rate that basically helps you increase your level of attention and arousal, complementary or like in synchrony. And that would be something that we can apply also in the office, like, you know, increase your level of stress by maybe increasing your breathing rate such that you can pay attention. So you're in a class and you're starting to feel drowsy and you're a student, and maybe raise your attention so you can actually listen to the professor better, you know, or other things like that. At the end of the day, some people actually who work in depression think that, you know, the reality of depression is that it's not so much the looming and, like, you know, sad elements. It's more that you lose interest. So you lose the ability to get aroused about things. And so you don't act. And that lack of activity is what is actually driving the depression. And that's why behavioral activation is such an important component of depression treatment. So in that case, we could also say, well, if you can increase arousal, you might be able to also support that behavioral activation, you know, angle. So I'm definitely pro like manipulating stress also up for when it's needed, for sure. Yeah. And breathing is a great mechanism. Yeah.
Excellent. Any other questions for Pablo? I guess I'll end with one last question. Then, so you touched on a little bit. Actually, it looks like we have another question, but so we'll do that one after mine. But I was curious about, you know, you touched a little bit on alert fatigue and, you know, providing data back to whoever's the user. Is that something, you know, is that something that's going to be necessary? Like, does it empower them? Does it stress them? Or is that some kind of progress that can be tracked in the back end and that's good enough?
That's actually the hardest question, I would say. Like, you know, there's like fatigue of like, not just sensor, but also not just intervention, but sensors too. Like, why would I be wearing this thing? Like, again, you know, I was wearing this ring who was really useful for my, you know, insomnia, and now I'm not wearing it. And in part, I feel a bit free because I felt like attached to that thing, you know, and I kind of broke free of that latch, right? So that's the hardest part. That's why I have anthropologists in my lab, because the real harder questions is like, how do we really get people to like adopt these like proactive behaviors in a meaningful way? A person who's perfectly fine, why should I be caring about my cardiovascular health, right? Like 20 years in advance. If that involves like wearing a device that I have to be wearing all the time or things like that. So that's why for me, peripheral, for example, the peripheral notion of interventions is a very interesting one. If you can do peripheral interventions that literally you don't have to do anything else, you just keep working and it regulates your breathing while you're working, could be an interesting opportunity, right? I mean, at the end of the day, these micro intervention, all of them do have like an element of disruption. And that element of disruption needs to be managed. I think the progression aspect is a very important one. If you feel like, you know, you're progressing towards something, maybe you want to keep doing it, like you're feeling like you're becoming a master of resilience or something, like Zen master or something. I think that's a hard proposition. I think you really need to be committed to that. I think the most important one is to make sure that you know how to like do a push and pull type of like model, where sometimes you actually support and you increase maybe the frequency of support. Sometimes you just back off and say like, you know, people just don't want to get this thing. And then, you know, keep adapting to the novelty and interests of people such that, you know, you keep like going. I always say it's maybe like a Coca-Cola model, right? Where you keep drinking the same drink for the past 100 years, but it's the advertisement that makes you like interested in like drinking Coca-Cola, even though it's the same boring old cola, right? So it is a problem. It's a very interesting challenge. You know, that's a longitudinal, hard to measure, and this is something that precision health needs to work on, I think, heads on over time. Yeah.
Yeah, absolutely. Thanks, Pablo. And okay, one last question. They typed this out, so I want to make sure we honor it.
I can read it also. Yeah.
Okay. Yeah, sure.
Okay. So it's about like a common denominator of various stressors in your experience. Okay, I see. Yeah, okay. So I mean, I'm gonna make a very huge abstraction. I think definitely has a utility function, you know, stress attached to a utility function. And that's why I said like in the future, we cannot just study stress in isolation. It has to be combined with some other meaningful complementary signal like performance or learning or like some kind of like improvement in your life that might be useful either for you or for your employer or whoever or for the society in general, but it has to come together. Like for me, performance is the easiest because we know that performance and stress is linked. At least we know that in rats and the Yerkes-Dodson thing, but we don't have enough information on what is the real combination between these two things, right? I think at the end of the day, whether it's for the employer or for the user, it's a complicated also question, like, you know, what does it mean to increase performance? Is that something that you are benefiting from or not? One thing I can tell you is like from the procrastination perspective, the way that we have been looking at this problem, procrastination is a very conflicted problem for humans because it is not rational. Like why would you stop doing something that you need to do if that's gonna harm you at the end? Like it makes no sense. So it's really more an emotional process. It's like, oh, I'm feeling very stressed because, you know, I cannot accomplish, or I feel I cannot accomplish, or I'm tired of doing something, and then you stop doing something. But then it carries a tremendous like increased exacerbation on the stress. You feel more stress at the end of procrastination. It's not an intervention that reduces stress. So at the end of the day, for example, procrastination, which is a type of productivity problem, right, has an effect on the person and also the employer, because the employer doesn't get the benefits of the output because you didn't do it, and you don't get the benefits of the output because you put something for later and you get actually feeling better. So I think that situation like procrastination is actually something that benefits both. It's a win-win situation. There might be some other issues where you would say, well, if we like get people to work more and, you know, we just burn them out, you know, like a mill, like you know, like we're burning people out, then only the employer gets the benefits. I think the modern society is really concerned about that. We don't want to burn out people, right? We want people to continue to be productive over the long term, and that means we need a better balance of well-being over time.
Excellent. Well, thanks so much, Pablo. You know, this has been a great discussion, and really like seeing all your updates on the different interventions, and look forward to seeing how everything pans out for you.
Thank you so much.
It's always a pleasure, and look forward to seeing you back for our next seminar coming up shortly.
My pleasure. It's always a pleasure, Ryan and Ashley. Thank you so much. Thanks,
Excellent.
everybody.
Everyone have a great day.